Magic 8 Ball, will they pass the algebra regents? My sources say no. Oh my gosh. Well, what are we going to do? We're going to prove them wrong because you will pass that Algebra 1 regents. Good morning, everybody. Let's do this. So you've been progressing so well in this course. It's been really nice to see. We've known each other for how long? 3 months? Can you imagine another 3 more months together? Let's go. So you guys have been doing really well, and let's just keep the momentum going. There have been 2 important ideas that I want you to learn from today. Important idea number 1 and important idea number 2 that I've been seeing that has been confusing students. The first one is seeing the difference between these formulas. You're used to this, but you're a little shaky when you get this. And the other one is, how do you adjust the window so you could see this graph? So once we're done with these 2 things, this will complete the topic, right? We're almost done. Let's do this. Try hard mode activated. Let's have a quick little do now. What does it say? Below is a table of percents and decimals. Practice converting the percents to decimals, and then can you convert some of the decimals to percents? Let's see what you got. As Genesis loves to hear me say this all the time, pause the video and try this by yourself. All right, so just so you guys, if you need a little refresher, if you want to convert a percent to a decimal, think to the left, to the left. If I want to convert a decimal to a percent, think to the right, to the right. So what does this mean? So if I have this number 30, notice the decimal, you don't see it right here, but it's technically over here, right? So all you need to do is go la, la, and then right here, 0.30. What about 3%? Where's the point? It's right here. What do I do? La, la. And wherever there's a space between the decimal and some comma, where you go like this, you just put a 0, so you have 0.03. If you feel like you want to pause the video and try the others by yourself, you could do it. But if you want to just see the answers, let's see if I have 3.2, la, la. This is 0.032. If I have 0.5%, I go la, la, and then I have 0.005 as a decimal. You see, this one was la, la. Okay. Well, if I want to go the other way, if I want to convert decimal to percent, what do? Think to the right, to the right. So all I need to do is go la, la. And now the point is here, so if I have 50 like this, then that's 50%, right? 0.5, right? 0.5 is 50%. What's 0.05? 5%. What's 0.0527? Well, just go to the right, so it's going to be 5.27%. Okay? This one was a good one. If I have 1, the decimal is right here. So if I go la, la, 1 is 100%. 125% will be 1.25. Okay? Let's go. Let's keep the momentum going. Let's keep the momentum going. Turn the page. Turn the page. Okay? So here, what I really want us to learn is that important idea number 1. It's what is the difference between these 2? And I'm going to do a really, really good job of teaching it right now. So let's take a look at the ideas. You have this side will be exponential growth. This side will be exponential decay. What I'd like you to do is pause the video and try this by yourself. If you just copy what I do, you're never going to learn, okay? You got this. Try this by yourself before I review it. Let's see. Once upon a time, Mr. Gajari found a rare koala in his classroom. And oh no, he's lost his arms. Hold on, let me change the music real quick because we have an ad. Okay, let's try that again. Once upon a time, Mr. Gajari found a rare koala in the classroom who was missing an arm. As Fernando says, maybe he was in the wrong neighborhood. The value of the koala is $700 and it appreciates by 5% every year. Create an equation that models the story above. This, you should feel good, right? P, parentheses, 1 plus r to the t. 700, parentheses, 1. What's my percent? It's 5%. What is 5% as a decimal? It's 0.05. So it's 1 plus 0.05 to the t. Ja, done. Okay, next part. Let's take a look. Bobo the monkey said, hey, I think this equation also models the story. He wrote 700 times 1.05 to the x, right? So instead of to the t, I could also say to the x, right? Is he correct? How can you tell? Is there any way you could check on your calculator to see if the equation you created and Bobo's equation matches? Is he correct? Is this equation equal to this equation? Well, it is. Mr. Bobo is never wrong. Let's see why. Notice, what if I do 1 plus 0.05? Notice it gives me this 1.05. So notice that if I add this, it gives me that. So he is correct. And how can you tell? Because the insides over here match, this matches, that matches. But the most important thing is, how can you, and this is a Regents cheat code, if you know how to do this on the Regents, you're going to score points. How can you check to see if two equations are equal? What you do is you plug it into y equals and view the table. So let's take a look. If I go to y equals, let's plug in the first one we had, which was 700 parentheses 1 plus 0.05 close to the x. And what's the other one? 700 parentheses 1.05 close to the x. If I hit second graph and I look at the table, what do you notice? What do you notice? Notice that these are my x values, but these are my corresponding y values, and they are the same. You have the same y values. So that means this equation and this equation must match. They must match, okay? Now, what do you notice now that maybe you didn't realize before? What I want you to do is write something, and show me, right? Whenever you get the chance, pause the video, just say, hey, Mr. G or Miss Ahmed, I want to see this, right? And then share it with someone. You could poke them and say, hey, what did you write over here? What's something that you're noticing now? What I'd like you to do is, let's take a look at the next one, right? Once upon a time, Mr. Gajari drank some coffee. He has his coffee in the morning, right? And the coffee has 110 milligrams. Oh, I meant to write, oops, my bad, of caffeine. Okay? And the amount of caffeine diminishes by 8% every hour. So you have 110 milligrams of caffeine, and the caffeine in my body diminishes. That's a very fancy word. What should the equation be? Well, let's see. It should be 110, 1 minus 0.08 to the x, or to the t, right? Because 8% is the same as 0.08, okay? If you didn't get a chance to do this question, try it by yourself, right? But let's take a look. Bobo the monkey said, hey, I think this equation also matches this equation. Is he correct? How can you tell? Is there a way you could check it on the calculator? Well, is he correct? Is he correct? Yes, he is. Why is he correct? Well, what happens if you do 1 minus 0.08? Notice that if I do the 1 minus 0.08, you get 0.92, so then these two equations must match. They must match. Okay? What do you notice now that maybe you didn't realize before? Oh my gosh, I made a mistake here. This should be this one. This should be the 110 parentheses 0.92 to the x. Okay? What do you notice that's similar? All right, let's try the next page. And here, I forgot to add the t or the x. So if you notice on your page, it's blank. Sorry, yesterday was a very long day. But let's take a look and let's flip the script. This is the super important part of the lesson. What if you don't have a story and instead you're given this equation or you're given this equation? Take a chance, pause the video, try this by yourself. I know you can do this. I know you can do this, right? What's the initial amount? Does it represent exponential growth or exponential decay? How do you know? Okay. Well, let's see. Here, what is the initial amount? It's 450. Here, what's the initial amount? 350. Does this represent exponential growth? Yes. Exponential growth. And how do you know? And that's a really big important question. Here, this 1.075 is greater than 1. If the number is bigger than 1 in the center, then you're going to have exponential growth. What do you notice about this number? This 0.78, what's its relationship to 1? Pause the video, try and write the correct symbol, or what do you think I'm going to say? This is less than 1, right? This is greater than 1. If it's greater than 1, you have exponential growth. If you have less than 1, then you're going to have exponential decay. Now, this is for all the cookies and lollipops in the world. How do you know what percent it's increasing? How do you know what percent it's decreasing? Hint, use the formula. Use the formula. Pause the video. Try it by yourself. Try it by yourself. Can you get this by yourself? Well, let's see. Let's see. Let's take a look at this over here. There is a relationship between these two. Here, what has to be true about this 1.05 and this 1 plus r? They must be equal. They have to be equal because here this is the same. This is the same. So these have to be the same. They have to be equal to each other. Well, how will that help us? Let's say if I have 1.05 equals 1 plus r. What we want to do is, what is the value of r that when I add it to 1 gives me this? If you need to rewind the video and hear that again, please rewind it. What is the value of r? What value of r plus 1 will give me that? Well, how do you solve this equation? We haven't practiced this a lot, but what do you do? If I have 1.075 equals 1 plus r, how do I get this r by itself? All I have to do is subtract 1, and I subtract 1. If I subtract 1, and you could try this on the calculator real quick, what is 1.075 minus 1? Notice it's 0.075. So notice that r must equal 0.075. But how do you, then what's the next idea? What is this? Pause the video. What is 0.075 as a percent, right? What is this as a percent? It must be 7.5%. This 7.5% represents the percentage growth of the formula. It's growing by 7.5%. Right? So then what can I do? Try this one. This is your formula. How can you represent this equation in another way? Pause the video, right? How can you represent it in another way? Right? This is my 1 plus r. But you see, if I have this, then it's easy to see that it's 7.5% growth. But if I have this, you have to figure out what the growth is by setting up this formula. Okay? I hope this was okay. Try the other one. Try this one by yourself. Here, it is not decreasing by 78%. This is wrong. Wrong. It is not decreasing by 78%. Can you figure out what it will be? Pause the video. All right. We will go over this in class, right? If you could figure it out. What I want you to do is, when you're done, try this on your own. What's something you learned well today? Was there a moment today where you're like, oh, okay, this makes sense now? Where was that moment? You could answer these questions. Oh, that's the bell. I got to get ready for my first period class. Then try the Regents questions, okay? Try the Regents questions. I believe in you. You got this.